Good afternoon, students. Let's start our session today. Our session today will be a little bit intense. We'll be learning about IPv4 addressing. So I hope you have your attention with you. You have brought your attention. I'm recording the session anyway, and I will be uploading it. And I would be asking you to perhaps watch this again before you do the lab exercises. Okay. Today's lab exercise is not a packet tracer exercise. It's rather an IP addressing exercise. So you have to approach today's lab exercise by first understanding this IPv4 addressing. Okay, so we will be looking at IPv4 addressing and try and understand the concept. We will look at the address structure. What is IPv4 address structure? In IPv4, what is unicast, broadcast, and multicast? What are the different kinds of addresses we have in IPv4? What is a public and private and reserved IPv4 address? And how can we take IPv4 and segment it? In other words, what is subnetting? And how does it help us in segmenting? And in the first place, why do we segment? What is the purpose and what is the benefit? That's what we're going to go through today. And we will also learn how to subnet a IPv4 network. So the topic I'm going to teach you today is one of the single most important topic in the whole of CCNA 1, 2, and 3. So I request you all to give me your undivided attention if you can. Okay, thank you. Let's start today's session. IPv4 address structure. Now we know that IPv4 address structure has been there for a long time. And since we have got not enough IPv4 addresses, we have got a new address structure, which is IPv6. Now, let's not worry about IPv6 yet. Let's concentrate on IPv4 first. So it's a 32-bit hierarchical address that is made up of a network portion and a host portion. Okay, 32-bit. If you look, it consists of 4 octets. 1, 2, 3, 4, and each 8 bits. If you convert these decimal numbers into binary equivalent, this is what you get. And you have got 8 bits plus 8 bits plus 8 bits plus 8 bits. That would be 32 bits. Okay, 8 times 4 is equal to 32. Now, each of these bits, okay, is divided into 2 portions. The network portion of the IP address and the host portion of the IP address. Now, we know that the network portion always stays the same in the network. However, the host portion is changed. Every device gets a unique host portion address. Okay, as far as our IPv4 logical address is concerned. Okay, so every IPv4 address consists of 32 bits. Okay, and these 32 bits are divided into 4 octets. Each octet, 8 bits. Combine all the 8 bits, 8 plus 8 plus 8 plus 8, you get 32. And these 32 bits of IPv4 address is divided into 2 portions, network portion and host portion. The network portion in the network always remains the same. The host portion keeps changing depending on your devices. If you have got 10 devices, then perhaps you can start with 1 to 10 and so on. Okay, depends on the network address of your network. Okay, so this is IPv4. Now the question is, how do I distinguish which will be the network portion and which will be the host portion? In other words, you see, it says over here, there's a division. It says, hey, these 3 octets belong to the network, and this last octet belongs to the host. How do you determine this? You cannot just determine it without getting any information, detailed information. And that detailed information is given to you by subnet mask. When you have the subnet mask, then you know what is my network portion and what is my host portion. So if I give you a subnet mask like this, 255.255.255.0, then you have an idea that 255, if I convert it into binary, is 1111111. And again, this is converted into 1, this is converted into 1, 0 is converted into 0. So all the ones determine your network portion. So you know that the first 3 octets belong to the network. And since we have the last octet is all zeros, that means you have got 1, 2, 3, 4, 5, 6, 7, 8. 8 bits reserved for the host portion. So when you're giving an IP address to your device, you only can play around with this zeros. You cannot touch these. These are the network portion. So the subnet mask gives us an idea of what is the network portion and what is the host portion. Remember that. Okay. So if I give you an IP address, I will tell you what is the network portion, what is the host portion. What should be your question? You say, I don't know. What is your subnet mask? Okay. So in order to find out, as we discussed, the network portion and the host portion, we look at the subnet mask. Okay, looking at the subnet mask. When we look at the ones over here, immediately when you look at the ones, you know that these ones represent the network. The zeros represent the host portion. Immediately you know it. Okay. And using the IPv4 and the subnet mask, you can do another thing. You can find out the network address of your network. Okay. So if this is my subnet mask over here, okay, I can also represent this by saying /24. /24 means 24 bits are reserved. 255, 255, 255 means 24 bits. These ones means 24. 8 plus 8 plus 8. 24 bits is reserved for the network. Then how many bits are reserved for the devices for the host? 32 minus 24, which is 8. Get it? Now, next step, we need to find out the prefix, okay? So instead of showing the subnet mask in this way, showing it by using a prefix is much more efficient, okay? So rather than saying that, hey, your subnet mask is 255.0.0.0, it would be better to do it in this way, /8. The moment you see this /8, that means 8 bits are for the network, 24 bits, because 32 minus 8. So 24 bits are for the host. 24 bits for the host. Just imagine how many devices you can connect to this network. And so on. And so writing in 255.255.0.0, you can just represent it like this, /16. That means 16 bits for network, 16 bits for host. Okay? /24, 24 bits for network, like the previous example we had. Okay? Here, we have got 24 bits for the network and 8 bits for the host. There. Now, sometimes what you can do, you can go one step and borrow 1 bit from the host portion. Like here is 24. I take 1 bit from the host portion, and now my network is 25. You see how many ones I have? 24 plus 1. So the network is 25, and my host portion is not 8 anymore, just 7. Just count. 1, 2, 3, 4, 5, 6, 7. Only 7. And so on. You see? Now I take 2 bits from my host portion to increase from 24 to 26. So now my network portion is 26. My host portion is 6 bits only. And so on. /27, /28, /29. The last one is /30. Whereby you have got 30 network portion and the host portion is only 2. If you remember the formula, 2 to the power of 2 minus 2, that means we can have only 2 devices, only 2 hosts in this network. Okay? Now you may ask, why do we need this? Who's going to use this? There is a use. We'll look at it today, okay, to understand it better. So applying the formula, we know that total number of hosts in the network is equal to 2 to the power of host portion minus 2. I've already taught you this, okay? So what is the host portion? How do you calculate the host portion? Very simple. 32 minus the prefix length, okay? So let's, for example, look at /29, for example, okay? If let's say you take into example /29, we can say host portion is 29/29 means network portion is 29 bits. So the host portion is 32 minus 29 is equal to 3. Okay, is it correct? Count. 1, 2, 3. Yes, host portion is only 3 bits. So how many computers can I connect here? Just apply the formula. Okay, 2 to the power of host portion minus 2. That means 2 to the power of 3 minus 2. 2 to the power of 3 minus 2 is equal to 6 hosts. So a /29 network can only have 6 devices, not more than that. Okay. Another thing you have to be able to do is find out your network address. Okay. Network address is not a usable address. It just tells you, hey, this is my network address. Then the first IP address of that network address would be perhaps by adding a 1 by adding an incremented value to your host portion. What do I mean by that? I'll tell you. Look over here. I have got an IP version 4 address. The IP version 4 address I have is 192.168.10.10. I also have my subnet mask, which is 255.255.255.0. So I have been given my any IP address in my network, and I have been given my subnet mask. Now, once I have any IP address in my network and any subnet mask, now I can find out my network address. Okay? Now the question is, how do you find out your network address? Answer is very simple. You have to do something known as ANDing. What is ANDing? ANDing means take any IP address and your subnet mask and do a AND operation, which is 1 and 1 is always 1, 0 and 1 is 0, 1 and 0 is 0, 0 and 0 is 0. Okay? 1 representing true and 0 representing false. So just do an ANDing. Okay, take any IP address and your subnet mask and do an ANDing. So here 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, and so on. Go on doing the ANDing until you get the values. Okay, remember, you have to first convert your decimal IP address into binary, your decimal subnet mask into binary, and then you do an ANDing. Once you get the value, your ANDing value, then convert it into decimal, and you have your network address. So what is my network address? 192.168.10.1. Get it? Now, you should know that every network has got certain things that you have to be careful with. First, every network will have a network address. Like just now we did an ANDing and we found out that this network, the network address is 192.168.10.0. Okay? Every network will have a network address. The network address, you cannot use it. Okay? You can add a device by incrementing that network address. Okay? So in this case, for example, I cannot use this network address, but I can know that my first IP address will be 192.168.10.1. Okay? That would be my first IP address. So those IP addresses are my host addresses. In order to calculate my host addresses, I have to use the formula. And I will also have something known as a broadcast address. Broadcast address is my last host address plus one. Okay? So, for example, if I have my network address, as we discussed before, 192.168.10.0, I have got 192.168.10.0, okay, /24, that means network portion is 192.168.10, and host portion is 8 bits, 32 minus 24, 8 bits. So this is only change for the host. That's why you go router, this port is given 1, this computer is given 10, this laptop is given 55, this computer is given 101, this laptop is given 12, and so on. You can only play around with your host portion. Okay? Suhas, we don't have a packet tracer activity today. I told that in the beginning. Perhaps you came late. Can you stop chatting, my dear students, and pay attention to this session? This session is the fundamental session of all your CCNA. So you have to understand these concepts. And if there is any challenging topic in CCNA-1, you're looking at it. This is the one. Okay? So I need you all to pay attention. Thank you. Okay. So as I said, every network has got a network address, which we found out by calculating any IP address as well as the subnet mask. We did an ANDing and we found out our network address. And it also has got host address. So how many hosts I have over here? 1, 2, 3, 4, 5. Can I have more? Yes, you can have many hosts. How many hosts? You have to calculate. Okay, how? Look at your host portion. What is your host portion over here? 1, 2, 3, 4, 5, 6, 7, 8. Count the zeros. 8 zeros. So how many devices you can add to this network? 2 to the power of 8 minus 2. Get it? So that would be your host addresses. Broadcast address is your last host address plus 1. Okay? So remember, every network will have a subnet mask, will have a network address. You will have a first IP address, like I said here. If this is your network address, 1. You will have a last IP address. Okay? So if we apply the formula over here to our network address, you see the host portion, 8 bits, 2 to the power of 8 minus 2. That means 254. 256 minus 2, 254. So the first address will be 1. The last address will be 254. Then what is the broadcast address? The last address plus 1. which is 255. Get it? You have to understand this, because in the exam and the lab that you're going to do today, okay, it's not a packet tracer lab, it's a calculation lab. And you have to understand this because you have to show what is your network address, what is your host address, what is your broadcast address, and you have to show your ending. Now, sometimes what students do, they go online and they use an IP calculator. Okay, you don't do that, please, because in your skill-based exam, I will ask you on the spot, how did you calculate? Show me your ending. Okay. So you should know these things, my dear students. And, there's no shortcut. You have to understand it. So remember, every network has got network address, host address, broadcast address. Now, having that in mind, let's go back to this. I was given an IP address. I was given a subnet mask. And using ending, I calculated my network address, okay, which was 192.168.10.0 by using ending. Next, I want to find out how many hosts can I have in this network. Again, I'm repeating what I said before. What I'll do, I'll go to the host portion. This is my network portion. Host portion, how do you know this is your host portion? Just look at the zeros, count the zeros. Okay, look at your subnet mask. This is your host portion. The zeros means host portion. So 8, 2 to the power of 8 minus 2. That would be 254 devices can be added to this network. Network 192.168.10.0 can have 254 devices. We don't care whether they are computers, whether they are IP phones, whether they are IoT devices. We don't care. 254 devices can be joined to this network. What we care is, what is the first IP address? The first IP address will be 192.168.10.1. Okay, looking at this will be 1. What is the last IP address? 192.168.10.254. And what is the broadcast address? Just take the last IP address and add 1. Okay, that is the reason, my dear students, we say 2 to the power of host portions minus 2. Why do you think we say minus 2? Because the first address is the network and the last one is the broadcast. We cannot use this. We cannot use this. We can use everything else in between. Get it? That is the reason we say minus 2. Now, this is very straightforward. Now, I'm going to complicate it a bit. And let's do another one where we complicate it so that if we get this kind of question in our skill-based exam, we can still find out what is my network address, what is my first IP address, last IP address, and what is my broadcast address. Now, pay attention. This is very important. Let's say my IP address given is 192.168.200.149. I've given you this IP address. Now I tell you which is the host portion and which is the network portion. You stare at me and you say, excuse me, what is the subnet mask? You cannot just tell me, give me this IP address and tell me which is the host portion and which is the network portion. Give me a subnet mask so I know. Then I give you a subnet mask. Now that I've given you a subnet mask, you know exactly which is the host portion and which is the network portion. Okay? All you have to do is convert this into binary format. And once you convert it into binary, just count the ones. The ones means that is the network portion. The zeros means that is the host portion. That's it. Okay, but this is not straightforward like the previous ones. You see, previous one we had .0. Now this is .224. So you have to convert it into binary format. Now I've given you this IP address. I've given you the subnet mask, and I'm going to ask you, what is the network address? So what you're going to do? You're going to do ANDing and solve the problem. Let's do it together. Okay. How do we do ANDing in this situation? First, convert this IP address into binary format. Done. 192 converted, 168 converted, 200 converted, 149 converted. Next, convert your subnet mask into binary format. Done. Converted. Okay, so 255 means all are ones, all are ones, all are ones. 224 means 1110. The moment you convert 224 into binary format, just looking at this, you know that this network consists of 8 plus 8 plus 8, 24, 25, 26, 27. 27, okay? It's a /27 network bits. But how many host bits do we have? 1, 2, 3, 4, 5. Count the zeros for host. 5 host bits. Okay, so how many computers we can have here? 2 to the power of 5 minus 2. Again, I use the word computer. I should use the word device. Okay. So once we have the IP address and the subnet mask, now I can find out my network address. How? By using ANDing. Okay. 1 and 1 will be 1. 1 and 1 will be 1. 0, 1, 0, 0, 0, 0, 0, 0. There. The second one, 1, 0, 1, 0, 1, 0, 0, 0. There. The third one, 1, 1, 0, 0, 1, 0, 0, 0. Okay, there. Last one, 1, 0, 0, 0, 0, 0, 0, 0. There we go. So this is my network address. So we just convert it back into decimal. So this one would be 192.168.200.128. This is my network address. How did you calculate this network address? By taking any IP address and the subnet mask. Doing ANDing, you can come out with your network address. Okay. Before I proceed, let me clarify the question. Can we just ignore doing the binary format for the IP address part? There's no 255 addresses, they are going to be the same. Yes, you can. Because as you go ahead, you would be, I mean, it would be second nature to you as network engineers. But how do you do a calculation for this kind of subnet mask? You have to do an ANDing so that you get your network address. Okay, and you have to show me this process of ANDing, because students, they want to take shortcuts. They go online and use IP calculators. I don't want you to do that. I want you to understand how it's done. Okay, so now that you have your network address, remember, can I use this IP address? No, this is my network address. However, I can append over here. For example, my first IP address will be 129. First of all, how many IP addresses can I have in this network? Look at the subnet mask. Look at the zeros. 1, 2, 3, 4, 5. Okay. So the question is, total number of hosts in the network is 2 to the power of host portion. Host portion, looking at the subnet mask, consists of 1, 2, 3, 4, 5. 5 zeros. So 5 host portion. 2 to the power of 5 minus 2. Okay? 2 times 2 times 2 times 2 times 2. Okay? That would give you 2 to the power of 5 minus 2. That would be 30 devices can be connected to this network. Okay? So, if we have got 30 devices, what is the first IP address? The first IP address will be 129. Okay? First IP address is 192.168.200.129. What is the last IP address? 30 plus 128. That would be 158. What is the broadcast address? The last IP address plus 1. So the broadcast address is 192.168.200.159. Get the idea, my dear students? This is how you calculate.
Sir, can you please repeat how did you get the last IP address 158?
Okay, this is a video recording, so when I upload it, you can keep on repeating it. But I will repeat again for the benefit of you and everybody else. See, first I have my IP address and I have got a subnet mask, correct? Now I convert my IP address just like before. I convert my IP address into binary format, and I convert my subnet mask into binary format. Using the process of ANDing, I find out my network address. Okay. Now that I have my network address, I know that my network address is 192.168.200.128. Remember, the network address cannot be used. Okay. But I can add devices by using this network address. Now, the question is, how many devices can I have in this network? Look at the subnet mask. Subnet mask says, over here, you have got how many bits? 8 plus 8 plus 8. 24, 25, 26, 27. 27 bits are reserved for the network. You cannot touch it. 0, 0, 0, 0. 5 zeros. That means 5 bits are reserved for the host. So just calculate. 2 to the power of 5. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. 16 times 2 is 32. 32 minus 2 is equal to 30 devices. Okay? So I know that in this network, what is the network? In 192.168.200.128 network, I can have 30 devices only. So my first IP address will start with 129. Remember, just like a previous one, 0. Network address is 0. The first IP address is 1. But here, my network address is 128. So I have to start with 129, 30 devices, then 130, 31, 32, 33, all the way to 158. Okay, so 128 plus 30, that would be 158. So your last IP address would be 158. And what is your broadcast address? Just take your last IP address and add 1. That would be 159. Okay, is it much clearer now?
Yeah, thank you.
Okay. The thing is, when you're watching the video, it will be repeated twice. So I hope you understand it. Because if you want to solve the lab exercises for today, you have to understand these things. Okay? So the whole idea is watching this over and over again and understanding it. That is why even if you go to previous semester, the most watched video is this video because students have to understand the concept. Okay, and the first time always you have to listen to it multiple times so that you get the concepts and understand. Okay. Okay. Now that you know this, you can solve some of your lab exercises. Now let's go further and understand some basic concepts about unicast, broadcast, and multicast in IP version 4. If you're sending perhaps a transmission from one IP address to, let's say, this IP address, you see, then you are perhaps doing a unicast. Okay, you have got one IP address and you have got the destination IP address. Okay, so there, straightforward, a unicast. If you're doing perhaps a broadcast, what you're doing is you're sending from one device to all the other devices in the network. Okay. So what you're doing is a broadcast. So if you remember, our switch is a broadcast device and our router terminates the broadcast. Okay. Multicast is when you are sending a packet to a series of addresses, or in other words, to an address group. So from 172.72.16.4.1, okay, from this network, from here, I'm sending into perhaps only a group of multicast address. For example, this two, let's say notebooks, they have got a multicast group address, which is 224.10.10.5, 224.10.10.5. So if I send it, only these two devices will receive. Others will not receive it. Okay. So we know what is unicast, what is broadcast, and what is multicast. Okay. Now let's go and see the different kinds of IPv4 addressing. Okay. We haven't come to the difficult part yet. Okay, so brace yourself. Okay, I'll tell you the challenging part when we come to it. So as per Internet's request for comments 1918, public IPv4 addresses are globally routed between ISPs. Okay, now public IP addresses, as you know, we are running out of. Okay, we have got a series of 4 billion public addresses. The exact number, I'm not so sure. And we are running out of it. That's why we came out with new solutions. Okay. We came out with IPv6. Okay. But private addresses, we still can use IPv4. No issues. Public addresses, no. Maybe that's why we have come with solutions like temporary solutions like NAT, and then permanent solution like IPv6, okay? And they have calculated, based on how many devices we're going to have in the future, and the IoT trend, and they have calculated that we will need a new IP addressing system perhaps after a century or more, in the next century or something like that. Okay. Now, when it comes to public IP addresses, we may not have enough. But private IP addresses, we still can use IPv4. That's why IPv4 is very important. Okay. So private addresses are common blocks of addresses used by most organizations, and usually they are divided into these three. Okay. 10.0.0.0/8. When you say /8, that means network portion is 8 bits and host portion is 24 bits, 24 host portion. Okay. So if this is your network address, this would be your broadcast address. Okay. So just imagine how many devices you can have. That would be 2 to the power of 32 minus 8, 24. 2 to the power of 24 minus 2. Okay. We also have another private address, which is 172.16.0.0/12. /12 means network address will be 12. Host portion will be 20. So how many devices we can have over here? 2 to the power of 20 minus 2. Another example. 192.168.0.0/16. So here we'll have 16 for network, 16 bits for network, and 16 bits for host. How many devices? 2 to the power of 16 minus 2. Okay. This is for your intranet. The issue with this is you cannot make this address public address and say that henceforth this computer, this server, this Moodle server is going to be 192.168.0.0.1. You cannot do that because there may be another computer somewhere else in the world with the same IP address. Okay, so there'll be a conflict. That's why we call it private addresses. Okay, and this is the range of it. Okay, now a temporary solution, I think we have studied this before, but let's try again. A temporary solution before we had our IPv6 was NAT. network address translation, whereby we take the private address, okay, and convert it into a global public address, okay, where on our routers, to be exact, on our edge routers. So what does NAT do? It translates the internal private address to a public global IP address. Okay? So you can have a NAT enabled on these routers so that whatever IP address you have here, there will be mapped to a global address. Besides that, we also have certain reserved addresses like loopback address. You can type 127.0.0.1. You can ping this to check whether your TCP/IP is up and running. If you get a reply, yes, it's up and running. Okay, we studied this as well in your lecture portion. In IP version 6, all you have to do is type ::1. That would be your loopback address. We also have a link local address. Okay, this is used by Windows DHCP clients to get a DHCP IP address when you don't have any DHCP server available. Okay, because you can either give your IP address, we study this in the lab, we can give an IP address statically or dynamically. So far, we have given the IP address ourselves, not dynamically. Dynamically, what it does is it looks for a DHCP server, which can be a computer, which can be a router, or perhaps a switch. And once it finds a DHCP device, it will take that address given by the DHCP server. But if it doesn't find, then it can automatically assign itself a link local address. Now, earlier, according to RFC 790 in 1981, it was out, we had allocated some class of addresses, but we are not adhering to this anymore, okay? Class A had this range, okay? You can see Class A, and it can have a total of 128 networks, and total number of hosts you can have is 16 million over, okay? Class B, this was the range, and per network you can have 65,000 hosts. You have a Class C for smaller networks, where you have got 254 devices, okay? So this had been earlier, set Class A, Class B, and Class D, this would be the range, and Class E, this would be the range, okay? So this class full address allocation was replaced with classless address, which ignores the rules of A, B, and C. No need to follow these. Okay, you can actually change. So your Internet Assigned Numbers Authority, IANA, manages and allocates blocks of IP version 4 and IP version 6 addresses. Okay, we didn't have enough public IP version 4 address. So what we did was we came with IP version 6 address, okay? And IANA, it has got 5 regional internet registries, okay? Like we have got one for North America, ARIN. We have got one for South America, which also includes Mexico, okay? LAC NIC. We have got one for Africa, AFRI, NIC. We have got one for Asia, APNIC, and we have got one for Europe and the Middle East, which is RIPE NCC. Okay, which also includes Greenland, because Greenland is a part of Denmark. Okay, yeah, part of Denmark. So that is also part of your Europe. Yes, ARIN only consists of Canada and USA. Okay, so these are the regional internet registries, and they are responsible for giving IP addresses to the internet service providers. For example, let's say APNIC will allocate what are the telecoms ISP addresses. Okay. And then, for example, the ISPs in Malaysia will segment their network and give to others. And that's how the internet works. Okay. Now, here it is, the challenging part, and I need your attention. Okay. Network segmentation. How do we take a network and we divide it into segments? Now, on the surface, you look at this, everything looks good. You got the internet, which comes through a router and then goes through your network. You have got 4 switches over here. Okay. The issue with switches is switches propagate broadcast networks. So the more switches you have, perhaps that may introduce some kind of latency in your network. The only device which breaks a broadcast is your router. We studied this even in the tutorial we did this week. Okay? Because routers do not propagate broadcast. Now, the issue with large broadcast domain is they can create so many broadcasts which can negatively affect our network. So one situation to improve this kind of issue is take your large network and segment it. In other words, take a large network and divide it into further smaller networks. Segmentation we call subnetting. Okay. For example, I have got one network over here, 172.16.0.0. This is my network address, /16. That means 16 bits network portion, 16 bits host portion. Okay. How many users I have here? 400 users. 16 bits. 2 to the power of 16 minus 2 is equal to, yes, definitely more than 400 users. Okay. Now just imagine you have got 400 users, and if you're using a common switch like we have in our lab consisting of 24 ports, how many switches do you need for 400 users? And every switch you add, you are increasing the broadcast domain, correct? So rather than doing this, what we do is we take this network 172.16.0.0 and divide this or subnet it into 2 subnets by borrowing another 8 bits from the host. You see, this is 16 bits network, 16 bits host. Now I take 8 bits. I take 8 bits from the host and make this 24. So now I have taken this and subdivided into 2 subnets. Okay, /24/24. I repeat again to tell you what I've done. Look here. I've taken over here. This is 16, means 16 network bits, 16 host bits. Now I take 8 bits from the host and add it here. 16 plus 8, 24. So now I have got 8 host bits for this network, 8 host bits for this network. In other words, over here you have got 16 bits for network portion, 16 bits for host portion. Now that host portion 16, I've divided into 2 parts. Okay? 8 bits here, 8 bits here. So this is one subnet, this is another subnet. This subnet, the network address is 172.16.0.0. This subnet is 172.16.1.0. Get the idea, my dear students? Now, how many users? There, 32 minus 24 is equal to 8. 2 to the power of 8 minus 2, 254. Yes, it can have 200 users easily. This also can have 200 users. So this is subnetting, taking a large network and dividing it into subnets. The benefit of this is you would be decreasing the broadcast. Okay? And you have to remember, if you have got different networks, different subnets, the only way these subnets can communicate with each other is through a router. Without a router, the subnets cannot talk to each other. Hence, since the beginning, since the first session I told you, a switch is used to connect the same network. A router is used to connect different networks. What do I mean by that? I mean, this network address is different from this network address. But no worries. Although they cannot communicate directly with each other, we have got a magical device called a router which can enable them to communicate with each other. Okay? Now let's go more into subnetting. First of all, why do we subnet? First of all, we have to understand what is the benefit of subnetting. It reduces network traffic and improves performance. Yes, if your network is slow, as a network engineer, when you go to any place and you see the network is slow, go and ask them, how many routers do you have in your network and how many switches? If they have got computers connected to one switch and then to another switch, then to aggregate switch and then to switch, and then there is one router, definitely the place will be slow. The network will be slow. Then you have to suggest to them, hey, why don't you subnet? You can also have security. Okay. It can also reduce the number of devices affected by abnormal broadcast traffic. For example, if you have got a building, a tall building, and each level is perhaps responsible for something. Okay, you know, in Curtin, Sarawak, if you go, we have got a lot of land. Our campus is very widespread. But certain campuses, for example, if you go to Hong Kong, and you go to Polytechnic University in Hong Kong, you will observe that in Hong Kong, land is not, very difficult to come by and it's very expensive. So what they do is they build vertically. So this could be perhaps what Hong Kong University uses. We have got different subnets over here, and each could be one department, or each could be perhaps one faculty or something like that. Or you can have reasons like administration department, human resource department, students department, accounting department. Again, the reasons it says security and protecting from abnormal broadcasts. Like human resource, you want to make sure that only authorized person can access the files in there. Not everybody should be able to access the files in there. Okay. And also about what kind of devices do you use. Now let's go and understand more about subnetting. Taking an IPv4 network and subdividing it into smaller networks. Okay. Now this is the single most challenging thing in CCNA 1, 2, and 3. So you have to understand this so you can go ahead. So usually, if we have got a /8 network, we know that network portion is 8 bits. Host portion is, count the zeros, 24 bits. So using this formula, 2 to the power of 24 minus 2, we can have 16 million, more than 16 million devices. /16, that means network portion, 16 bits, host portion, 16 bits. 2 to the power of 16 minus 2, we can have more than 65,000 devices. And if you have a smaller network, /24, that means 24 bits for network portion and 8 bits for host portion. 2 to the power of 8 minus 2, that means 254 devices. Okay, so if you notice, Using longer prefix lengths decreases the number of hosts per subnet. Okay? So you can easily subnet by 8, 16, and 24. And actually, you can go beyond that. Let's have a look. For example, in a network which is /8, okay, that means network bits is 8 bits and host is 24 bits. If you want to subnet it by using, let's say I want to subnet this by using /16, okay? So if I do /16, I can create 256 possible subnets, okay? Now, how do you calculate that? How can you calculate that? It's very simple. You see, this is /8, correct? Now, if I want to make it /16, that means I have to borrow 8 bits to make it /16. When I borrow 8 bits from the host portion, that means 2 to the power of 8 is equal to 256 subnets can be created. So this one can be converted to this. That means you can have 256 subnets, starting with this all the way until this. Okay, that means the IP, the network address starting from here all the way until here. These are the possible host range and the possible broadcast. Okay. What if you want to make it, okay, instead of /8, you want to make /24. 8 to 16 is 8. 8 to 24 is 16. So how many subnets you can make? Just if you're going from 8 to 24, that means 2 to the power of 16. That will give you 65,536 subnets. So this would be the range starting from this network all the way until this network, along with the broadcast. Okay? So look at how many subnets you can make. This is if you're converting a 8-bit network portion and 24-bit network and 24-bit host portion. Okay? So we can subnet this into 16 bits. We can also subnet this into 24 bits. If you're subnetting this into 16 bits network, then we'll have 256 possible subnets. If we are converting this into a /24 mask, okay, if we are converting this, subnetting this into /24, that means you're going from 8 to 24. 8 to 24 means you're borrowing 16 bits from the host portion. So 2 to the power of 16 will be this many subnets. Okay? We can also subnet a /24 network. Okay? If you have a /24 network, that means network portion is 24 bits, host portion is 8 bits. Now, this is very straightforward. If host portion is 8 bits, how many devices? 2 to the power of 8 minus 2 is equal to 254 devices. But wait a minute. Now, instead of making it a /24 network, I want to subnet. How? I want to subnet it into /25. /25 means borrow 1 bit from the host portion. When you borrow 1 bit from the host portion, remember the formula? Remember the formula over here? When you borrow 1 bit from the host portion, the formula is 2 to the power of 1. So for a /25 network, okay, how many subnets you can create? 2 subnets. This is a /24 network. If you want to subnet it, if you create /25, you create 2 subnets. If it is slash 26, that means you borrow 2 bits from the host portion. Then it becomes 26. So it is 8 plus 8 plus 8, 24, 25, 26. Okay. Then your subnet mask will be this, taking into account, because if you convert 11000000, that will be 192. This will be your subnet mask. So for slash 26, how many subnets you can create? There, 2 has been borrowed. So 2 to the power of 2 means 4 subnets. For slash 27, you have to take another 3 from the host portion and add it to the network portion. So 2 to the power of 3, that means 8 subnets. For slash 28 network, you have to take 4 bits from the host portion. So 2 to the power of 4, that means 16 subnets, and so on. Here, you're taking 5 bits from the host. Here, you're taking 6 bits from the host. So that means 64, 32 subnets. Okay? But no matter how many subnets you have, all you have to do is count the zeros to calculate how many devices. Like here, 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7 minus 2, that means 126 devices. 1, 2, 3, 4. 2 to the power of 4 minus 2, that means only 14 devices. Here, 1, 2. 2 to the power of 2 minus 2, that means only 2 devices. But 64 subnets. Okay, now you may ask, what is the use of this? I don't understand. Why do we need this? Yes, we need. You will understand it very soon. Okay, so you can take a slash 24 network and also subnet it like this. Okay, and be careful in your skill-based exam. I'm going to give you something like this and then ask you, give me my network address, give me the first IP address, give me the last IP address, and give me your broadcast address. And you should know how to calculate. Okay? So let's subnet a slash 16 and a slash 8 prefix. Okay, for example, here, a slash 16 prefix, that means you have got 16 bits for the host, 16 bits for the network portion and 16 bits for the host portion. But now you are borrowing 1 bit from the host, so making it 17. So how many subnets you can create in slash 17? When you're borrowing 1, remember 2 to the power of 1, that means only 2 subnets. When you're borrowing 2 bits, that means 2 to the power of 2. So slash 18, 4 subnets, and so on. Slash 19, 8 subnets. Slash 24, if you're taking a 16 slash 16 and making it slash 24, you are creating 256 subnets. Slash 29, 8,192 subnets. Okay, so as a network engineer, it will be good for you to have this table and refer to this table. Okay, so how do they do it? I've already taught you that. Let's repeat it. For example, if you have got a slash 16 network, you know that 16 bits is for network, 16 for network, 16 for host. If you borrow 1 bit from the host, that means you can create 2 to the power of 1, 2 subnets. So instead of 16, that network will be called 17. If you borrow 2 bits from the host, that network will not be 16 anymore. It will be an 18 network. And how many subnets? Since you're borrowing 2 bits, 2 to the power of 2, that means 4 subnets. If you are taking, let's say, the whole 8 bits from the host, okay, that means 2 to the power of 8, that is 256 subnets, okay, then that will be 24. So if you are making slash 16 to slash 24, that means you can create 256 subnets. Each subnet can have 254 devices. Okay, devices are very easy to calculate. Just calculate the zeros. Like here, this is /18. Okay, 4 subnets. Each subnet, okay, each subnet is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2 to the power of 14 minus 2 will be 16,382 devices. Okay? You have to follow this. You have to calculate this and understand this. Otherwise, your IP addresses will not work. They will not communicate with each other as far as IP version 4 is concerned. Okay? So understand the concept. Okay? So if you are borrowing 11 bits, then you can have 2 to the power of 11, 2048 subnets. Okay? Something like this. 11 bits means 2048 subnets. This is if you are having a /16 prefix. Okay? For example, consider a small ISP that requires 1,000 subnets for its clients. Okay? Yes. Using network address 10.0.0.0/8. It's a /8 network. That means 8 bits for the network and 24 bits for the host. Yes, 8 bits for the network and 24 bits for the host. Okay? 8 bits for the network, 24 bits for the host. So, the figure displays the number of subnets that can be created when borrowing bits from the second and third. So, if you want to take this and let's say you want to create 2 subnets, then instead of making /8, make it /9. There, you have got 2 subnets. If you want to create 128 subnets, then you have to take 7 more host bits, 8 plus 7. Okay, so you can create 128 subnets. Okay, so that would be a /15 network and so on. Okay, now I wouldn't bet that you understand this at the first time. That's why it's very important for this lesson to be really understood before you do the lab exercise for this. So let's do some calculation of subnets so that we drive this knowledge home. Okay, usually an enterprise network will have its internal network. It will have a public address network known as DMZ, okay, where you have your public addresses, and you will have a router and firewall to the internet. Okay, so we can say that a company could use a 10.0.0 IP address /8. That means 8 bits are for network portion and 24 bits is for host portion. But you can still subnet by making it 16 or 24 network. Okay, a /16 or a /24 network. If you want further subnets, you just go beyond. So when you create a subnet, you have to remember 2 things. Number 1, how many subnets do you want? Number 2, how many devices do you want per subnet? And then looking at this table, you can straight away figure out, okay, for a network which is like a /24, I want 16 subnets, and each subnet I want 14 computers, or let's say 10 computers. Then your network will be a /28 network, whereby you have to borrow 4 bits from the host and add it to the network portion. So 8 plus 8 plus 8, 24 plus 4, 28, /28 network. That means you have got only 4 bits for the host. 2 to the power of 4 minus 2. That will means only 14 devices per subnet. Okay. Let's look at this example. Okay, so to drive our knowledge home, this example is very good. In this example, corporate headquarters has been allocated a public network address of 172.16.0.0/22/22. That means network address is 22 bits. Host address is 32 minus 22, which is 10 host bits. Okay, so here, if we count, this should be 22 bits, and this one is 8 plus 2, 10. Okay, so how many hosts we can have in this network? 2 to the power of 10 minus 2. That means 1,022 hosts. Okay, now this IP address has been given to us by our internet service provider. Now what we have to do is take this IP address and divide it into 10 separate subnets. Why? Because in our company, we have got 5 sites and 5 internet connections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? From the ISP. Because remember, from this router to the ISP is also one network. So 10 subnets. Okay? We are going to allocate 10 subnets with a /26. So we are converting this /22 to /26. That means this is 22. In order to make it 26, 23, 24, 25, 20, you have to borrow 4 more host bits and bring it to the network. So we are converting 22 to 26. So refer to the table. Remember, you're coming from /22. Okay? So you have to, since you're coming from /22, that means you have to refer to your /16. Okay? There we go. /22. This is where you are. Okay, this is your subnet mask. And here is your host portion. And based on the calculation, it is right. We have got 1,022. Now it says, hey, I want you to have 10 subnets, and each subnet, let's say, it says each subnet, does it say how many host bits? Yeah, each subnet should have at least 40 addresses. Okay, so at least 40 addresses. So we were here. Now we are going to make it /26. There, 62 addresses. Can we make it /27? Yes. But the problem is only 30 addresses. Here it says we need at least 40 addresses. So which is the better option? Obviously, /26. Okay. So where we take, remember, we were over here. Now we are going to 26. So we are further taking some host portions and adding it to the network bits. So we can have 1, 2, 3, 4, 5, 6. 2 to the power of 6 minus 2, that means 62 devices, which is okay because we only need 40 addresses. Now we can follow for each subnet a separate network address. This would be one network, okay, 16.0.64, 16.0.192, 16.1.64, 16.1.192, okay, 16.2.64. And then here also you see every network is separate. Because it's /26, we can give different range. Okay, we can have 1,024 subnets, but we only need 10. Okay, so this is an idea for you. Okay. Another aspect you have to understand, my dear students, is the concept of VLSM, variable length subnet mask. This is also important. Look at this topology. How many subnets do we need? One network A, network B, network C, network D, perhaps all on a building. Very simple, 4 subnets. We can say that only building D uses the highest, which is 28 hosts, correct? And we are using a /24 mask. A /24 means it comes from 24. 24 means 24 bits network and 8 bits host. But here, when you say /27, that means you have taken 3 bits from the host and made it 27. Okay, 32 minus 27. That means you have got only 5 bits in the host. 2 to the power of 5 minus 2 devices you can add, which is okay. The question is, if you have got a network here, okay, which can have 2 to the power of 5 minus 2, how many devices we can have? 2 to the power of 5, which is 2 times 2, 4, 8, 16, 32. 30 devices here, 30 devices here, 30 devices here, 30 devices here. But wait a minute, we also have to connect the routers to each other, right? Router to router, router to router, router to router. So 1, 2, 3, 4, 5, 6, 7. Okay? So we can have a /27. As we look here, we can have a /27 to create 8 subnets, which is very good. You see, 1, 2, 3, 4, 5, 6, 7. That's it. We don't need 8 subnets. We only need 7 in this situation. And as it says here, you want 7, okay? And each can have 30, which is, again, very good. But the issue is, my dear students, if you look here, the issue is from this router to this router, how many hosts do you need? Do you need 30? No, you only need 2. So if you need 2, what you're doing is, if you look here, you are wasting 28. Okay, so here you have a capacity of giving, you have a capacity like here, 30 hosts, 30 hosts, 30 hosts. Just apply this formula, okay? Take 3 bits from the host, /27, make 24 into /27. So 8 subnets, each can have 30. Just apply the formula, 2 to the power of 5 minus 2, 30 devices. The issue is 30 devices here makes sense. 30 devices makes sense. Here, 5 are wasted. Here, 10 are wasted. Here, 15 are wasted. Here, only 2 are wasted. No worries. But here, only 2 hosts. That means router to router connection. Router to router connection. Only 2 hosts. So these 3 networks, you'll be wasting 28 addresses. So 28 times 3, 84 addresses are unused. So why do you want to do that? So that is why VLSM was developed. In VLSM, what we do is we take our subnet and again divide it, further divide it. So our /27 is further divided into /30. Remember, we said, why do we need /30? Doesn't make sense. Now you know why it makes sense. Why? Because when you say /30, that means 30 for the network, 2 for the host. 2 to the power of 2 minus 2 is equal to 2 devices. There. Device 1, device 2. Device 1, device 2. Device 1, device 2. Here, we can have 30 devices, 30 devices, 30 devices, 30 devices. Now, the other networks, we will subdivide them. We will subnet the subnet, okay, by creating a /30. So here, 2 devices, 2 devices, 2 devices. So after applying VLSM, you will have something like this, and this will ensure that you also do not waste your IP addresses. Okay. There. From R1 to R2, remember, only 2 devices. The network address is 224/30. The first IP address is 225. The second IP address is 226. The broadcast address is 227. This network is 228. You see, after 227 is 228, network address. The first IP address is 229. The second IP address is 230. The broadcast address is 231. Just add to that. This network address is 231 plus 1, 232. The first IP address is 233. The second IP address is 234. The broadcast address is 235, and so on. Okay, my dear students? So this is how you can not waste your IP addresses by taking your subnet and again subnetting your subnet. When you design your IP version 4 network, there are certain considerations that you can take. First is planning, so that you create a scalable solution to your network. Okay? You have to ask yourself the question, how many subnets? And each subnet, how many devices? Okay? What are the public addresses that I need to use? For example, my company is going to use a Moodle server, and it has to be on a public network. Okay? It has to be on the DMZ public, so that the internal network can access it, as well as the external network. Okay, something like that. So you have to ask, how will the subnet be structured? Do you have a DHCP server? In today's world, of course, you cannot survive without a DHCP server. A network engineer cannot go individually and give IP address to all the devices like we do in Packet Tracer until now. We don't. It doesn't make sense to do that. You have to have a DHCP server configured on your router or on your computers or something else. Okay. You have to ask yourselves the question: what are the different types of devices that require addresses? Okay. What are your servers and what are your peripherals? What are your end user clients? Do you have a DHCP computer? Do you have a database computer? Which servers have to be accessed from the internet? Are you going to have a NAT, or are you going to have an IP version 6? What are your intermediary devices? How many gateway devices you have? All these things, you have to actually draw a blueprint of your network. That's why network engineers do a lot of research on Packet Tracer. They develop a network. That's what you should also do. If you want to take this as your career and take this seriously, the returns is actually very good. The money generated in this field is really good, but you have to be serious with it. That's why we have got this simulation software Packet Tracer that enables us to create our own networks and, do research and try to find out which topology works, which subnet is a better option, which one is perhaps a hindrance. Okay. The more experience you have in this line, the better amount of pay you can demand. Okay. So that brings us to the end of IP version 4 session. Okay. Do we have any questions first? Now listen, I don't expect all of you to understand this topic. This is, I told you, if not one, it's the most challenging topic in the whole of this unit, CCNA-1. So that's why I want you all to go through this, okay, recording, and then do your lab exercise, because um, it takes a little bit of understanding. Okay, I'm going to stop the recording now.